Here are the lesson 8-2 solutions to the lettered problems. Our first problem has a radius of 2 and a height of 7 for our cone. So our volume is going to be pi times the radius, 2, squared times the height, which is 7, and then of course divide by 3. And it's a simple matter of putting everything into the calculator, rounding to the nearest tenth. You'll get 29.3 cubic feet. Remember cube for all volumes, cubic units. For letter B, they give us a diameter, and remember we need a radius, so since the diameter is 24, we divide it by 2, cut it in half, however you want to look at it, and we've got a radius of 12 and a height of 26. Very simple solution. Once again, it's pi times the radius, 12 squared, times the height, 26, and then divide by 3 to reduce it from a cylinder type of volume down to a cone type of volume by dividing by 3. And our volume ends up at 3,920.7 cubic millimeters in this case. Problem letter C, we have a radius of 1.5 and we have a height of 9. However, if you read the word problem carefully, there are 6 of these cones. So therefore, we're going to multiply by 6. We'll figure out the volume of one of them. Multiply by 6, we'll have the volume of all 6. So our volume formula is pi times the radius of 1.5 squared times 9, and then, which is the height, and then divide by 3. And then the last thing we have to do is multiply by 6 in order to get all 6 cones. Now there's multiple things that you could do here when you put this in your calculator. You could just recognize that 9 divided by 3 is 3, and then just simplify this to 3, and then of course that times 6 is 18, so you could just go do pi times 1.5 squared times 18. Doesn't really matter how you put it in the calculator as long as you type everything in carefully and get it correct. And we have 127.2 cubic inches for the volume of our piñata. Problem D, we have a left cone and we have a right cone. The cone on the left has a radius of 6 and a height of 5.5. The cone on the right has a radius of 6 also, and its height is 13. So we're going to calculate the volume of each of them and add them. The left cone plus the right cone will give us our total answer. So you can put pi times 6 is the radius squared times 5.5 for height divided by 6. And then for this volume, it's pi times the radius of 6 squared times 13 for the height, and then divide by 3. Now, once again, you can do this calculation, use the memory, and then add this calculation to it. But I think probably the easiest way for most kids is to parentheses here, and then plus parentheses here and here. Put this all in one string in your calculator. On those little blue calculators, you can even scroll back and forth to make sure you typed everything in correctly. Type it in exactly like this, and you will get 697.4 cubic inches for the volume of the 2 cones together. Please head to the guided practice. Okay, here are the solutions to 8-2 guided practice. In problem number 1, we have a radius of 14 and a height of 13. The volume, therefore, would be pi times 14 squared the radius times 13 the height divided by 3. Because it is a cone, we're dividing by 3. The answer is 2,668.3 cubic meters. Problem number 2 has a radius of 6, a height of 28. The volume, therefore, for this cone is pi times the radius squared, 6 squared, times the height of 28, divided by 3 because it's a cone. We get 1,055.6 cubic millimeters. Problem number 3. In this case, we're given a diameter. That's why I put it in red here, so you recognize that we need to switch it to a radius of 5 and a height of 9. So we have volume is pi times the radius 5 squared times the height 9 divided by 3 because it's a cone. And we get 235.6 cubic meters in this case. Problem number 4. We have a radius of 45, a height of 120. We can easily put it right into the calculation, and it would be pi times 45 squared, the radius, times the height of 120 divided by 3. What I did here is I recognized that 120 divided by 3 would be 40. So when I put it in my calculator, I just put pi times 45 squared times 40. Either way, you will get the answer. Probably would be a bad idea to double check it and convince yourself. And in this case, we get 254,469.0 cubic millimeters. You should have rounded to 0.0 here. Problem number 5. We have a cone and a cylinder. It's a composite solid, so we're going to add the two. The cone plus the cylinder, volume of the cone. Remember, because it's a cone, we'll divide by 3, so it's pi times radius squared of 5 squared times the height of 4 divided by 3. And then we're over here, because it is a cylinder, we are not going to divide by 3. Once people start doing cones, they tend to forget and they start dividing by 3 for cylinders as well. Please make sure you recognize only divide by 3 for cones, not for cylinders. Volume here is pi times the radius squared of 5 squared times the height of 3. Put parentheses around this and a plus sign, or use your memory, and you get 340.3 cubic centimeters. Problem number 6. We have a left cone and a right cone. They're both cones. We're going to divide both by 3. We have radius of 5 for both. We have a height of 13 on the left, a height of 10 on the right. Sorry about the ink here, where I'm having trouble because they're brand new boards. They're a little bit oily. It'll get better as they wear in. The volume of this one, and the way I would do this is put this in parentheses right away. Practice this. It would be a good thing for you to learn to do in your calculator. Left parenthesis pi times 5 squared is the radius times the height of 13 divided by 3. Right parenthesis. We're going to add the 2 because we want to add up the 2 different volumes. So it's add, or plus, left parenthesis pi times 5 squared, the radius, times the height of 10 divided by 3. Right parenthesis, put it in the calculator, 602.1 cubic inches. Lastly, problem number 6. The question is, which would have the greater effect? If I double the radius or if I double the height? Which is going to make the volume grow faster? And the answer is the radius, in most cases, will have the greatest effect, for the simple fact because it is squared. So it's kind of like the difference between 5 times 2 is 10, but 5 times 5, in other words 5 squared, is 25. So it's going to go much quicker. However, there is an exception. Think about that for a minute. Push pause if you have to. The exception to the radius being the most influential is when the radius is less than 1. If the radius is less than 1, like for example 1/2, if I square 1/2, I actually get 0.25 and it starts to reduce things. So that would be the exception when you have a radius less than 1.